Okay, in this video we're going to do a work calculation, and then using that work calculation we'll find the power, since this work will be happening in a specific amount of time. And then using that we'll convert the power into horsepower. So a 1,650 kilogram car accelerates from rest to 80 kilometers per hour in 7.4 seconds. Determine the average power of the car's acceleration in horsepower. So what we're assuming in this question is that the car is driving across level ground. It's going from, so the height is constant. That's the assumption that we're making. So it's going from rest 80 kilometers an hour. So the work that's being done is an increase in kinetic energy. We need to be a little careful here because the speed given here is in kilometers per hour. We need that in meters per second. So 80 kilometers per hour in meters per second works out to 22.2 meters per second. So with that in hand, we can go ahead and substitute into our kinetic energy formula. Here it started from rest, so it had no kinetic energy, so the work is just the total kinetic energy it ended with. So 1/2 times that mass, 1,650 kilograms, times the velocity, squared, so we can punch all that into the calculator and we get 407. Hold on a second here. 1650, 22.2. Oh, I don't know what happened there, but I did it again and I got a slightly different answer. So I got 406, 593, and that would be in kilogram meters squared per second squared. But remember, kilogram meter per second squared is a newton. That left off 1 meter, so this whole business here is really equal to a joule. So 406,593 joules. If that's the work, now we can use the time that it took, or 7.4 seconds, to figure out how much power the car had during that acceleration. Power is the amount of work done per unit time. So 406,593 joules divided by a time, 7.4 seconds. And we get a power of 54,945 watts. Or remember, 1 watt is equal to 1 joule per 1 second. 1 joule per second. So that gets us our power. And we were asked for that power in horsepower. Remember, 1 horsepower, I just looked this up on Wikipedia, is equal to 746 watts. So using that, I can make a fraction here to do this conversion. Canceling out watts on the bottom and introducing horsepower. That means 1 watt is equal to 746, or 1 horsepower is equal to 746 watts. Watts cancel. And so we would have 73.7 horsepower exerted by the car during the acceleration. So that's it. That's how you can use a change in energy to come up with a work amount done. Using the work, you can come up with the power, and then that's converted to horsepower.